In this video, we're going to prove a nice fact. It says if p and p squared plus 8 are both prime, then pq plus 4 is also prime. If you like watching videos like this where theorems are proved, subscribe to this channel, as that's all we do here. Okay, now if p is prime, then p greater than 3 is prime, then p is of the form 6m plus or minus 1. Well, let's square that and add 8. So p squared, let's say plus 8 right away, plus 8, it'll be 6m, be in the form of 6m plus or minus 1 squared plus 8. Well, that's going to be 6m all squared plus or minus 12m plus 1 plus 8. Well, that's 36m squared plus or minus 12m plus 9. But alright, the 9 as 6 plus 3. So in here, I can pull out a 6. But I get plus 3. So if this is prime, it's in the form of 6q plus 3. But if p is greater than 3, it can only be in the form of 6m plus 9. 6m plus or minus 1. So what that tells me is p is equal to 3 or p is equal to 2. So let's consider p equals 3. So p squared will be 9. And if you add 4, is it? No, if you add 8, you get 17, which is prime. And p cubed plus 4, p cubed plus 4 would be 3 cubed plus 4, which is 27 plus 4, which is 31. Now, if p is equal to 2, that implies p squared plus 8, that'll be 4 plus 8, which is 12. Well, that's not prime. That is, this and this are not both prime. Okay, so it violated the premise. If both of these numbers are prime, nobody's guaranteeing us that both p and p squared plus 8 are prime. But just in case they are, then p cubed plus 4 is prime. So we showed that. If p and p squared are prime, that implies that p squared plus 4 is prime. And that's exactly what we showed. There's only one way that, just looking at the proof, there's only one way that p squared plus 8 is prime. And that's if p squared plus 8 is not of the form 6q plus or minus 1. That means that p can't be bigger than 3. So p is 3 or p is 2. Okay, and once again, if p is 3, it did turn out that p squared plus 8, so p equals 3 is prime, and it did turn out that p squared plus 8 is also prime, and that did imply that p cubed plus 4, which is 31, is prime. P equals 2. The premise failed. When p is equal to 2, p squared plus 8 is going to be even. It's not prime. So nobody's saying that p cubed plus 4 will be prime or not. Just for fun, let's see. Well, if you cube an even number, you're going to get an even. And then if you add 4, you're going to get an even. So it turned out that p cubed plus 4 wasn't prime. But it didn't matter. It could have been prime. The theorem doesn't tell us anything about p cubed plus 4 because the premise hasn't been met. The premise is that both p and p cubed are both prime. If that, then p cubed plus 4 is also prime. We didn't meet it here. P equals 2 is prime, but p squared plus 8 is not prime. So we didn't live up to the if part. So this completes the video. It did show that, or the theorem, the proof, it showed that if p is 3 prime, if p is prime, and p squared plus 8 is prime, then p cubed plus 4 will also be prime. If you like watching math proofs like this, it's a no-brainer. Subscribe to my channel, as this is all we do. See you guys in the next video. Don't ever forget, watch and learn.